first grade teachers. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 5, problem solving to answer real-life questions. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 5. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. You may notice that some AKS and IOAs are repeated in this final unit and have appeared multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Unit 5 has one new AKS, AKS 5. AKS 5 has students use models, base 10 structure, and properties of operations to add and subtract within 100. Under the AKS, you will find the Indicators of Achievement, or IOAs. IOA 5A requires students to solve relevant addition and subtraction problems with both 1- and 2-digit whole numbers. Students will be expected to add and subtract with and without regrouping. Students can use a variety of strategies and should select the strategy that works best for them. For IOA 5B, students will mentally find 10 more or 10 less than a given 2-digit number. Students should be able to do this without counting and should be able to explain the reasoning used. Finally, IOA 5C requires students to add and subtract multiples of 10 within 100 and explain the reasoning used. In this unit, students will use background knowledge from AKS 1 and AKS 2 to efficiently solve addition and subtraction problems within 100. Students will apply the strategies and conceptual understanding that they use to solve addition and subtraction problems within 20 to solve real-life addition and subtraction problems within 100. In this portion of the video, we will dig into the unit pacing by looking at the pacing guide for Unit 5. Okay, so we have reached our Unit 5 in the pacing guide, which is problem solving to answer real-life questions. We see the big idea that we're going to be working with is numerical reasoning, and the suggested pacing is about 6 weeks. In the next box, we see the AKS, AKS 5, and the IOAs that are initially paced in the unit. So this first portion of the unit, we're going to be looking at IOA 5B, which is 10 more or 10 less than a given 2-digit number, and 5C, which is add and subtract multiples of 10 within 100. And then, of course, for both of those, you're explaining that reasoning that you're using. Before we dig into each day-by-day pacing, let's talk about the setup of the pacing guide. The left column of the pacing guide will list the progression through concrete, representational, and abstract strategies. The bullets are also going to indicate the learning objectives for the day, as well as outline any suggested manipulative that you might want to use for your lesson. The right column of the pacing guide shows the instructional resources that align to the intended learning objective for each day of instruction. Some days, like this day, you are going to see a traditional teacher-led lesson. So you're going to see the components listed for the traditional teacher-led lesson. Other days, which you'll see later on, you may notice a task-based lesson that's linked. That would be your entire math block for that day. So when we are looking at this first IOA, IOA 5B, finding 10 more or 10 less, we're starting at concrete and progressing representational abstract. And there are only 3 days for this. So there is some reasoning behind moving so quickly. Students do have previous experience from early in the year, counting forward and backwards by 10. They've also used counting strategies to determine numbers and patterns that grow and shrink by 10. So that is why there was only 3 days spent. You're also going to see these activating strategies, 10 more, 10 less, that are going to continue throughout the unit as well. So to continue to work on that. Next, we see that we have reached IOA 5C, which is adding and subtracting multiples of 10 within 100. Students will begin this work with base 10 blocks and then progress to representational strategies like drawing base 10 blocks. And on this day, I want to point out this structured inquiry lesson. We're going to open that up and take a look at it. So the structured inquiry lesson falls into our traditional teacher-led lesson framework. We're beginning with that activating strategy like we typically would. Then the teacher is going to let students know the teaching point or the purpose for today's lesson. So this is where it gets a little different. Instead of the teacher going into the teaching point, students are going to complete the active engagement portion of the lesson first. So while students are engaged in the active engagement, the teacher is going to utilize observations and decide what she really wants to focus on during the teach portion of the lesson. The teacher could highlight student strategies, make connections between their work, or maybe even show a strategy that no one used. Maybe there was a really efficient strategy that no one thought to use, and that was the strategy she wants to point out. So the purpose of that lesson is to really watch what the students do and decide exactly what you want your teaching point to be based on that. They have background knowledge in order to engage in this task. So we're letting them have the opportunity to do a little bit of the thinking before the teacher models. Okay, so that was our structured inquiry lesson for 5C for that representational. We're going to continue to work with 5C. We're going to utilize hundreds charts and number lines to really get them proficient with adding and subtracting multiples of 10 within 100. And then that final day is your abstract day. Now we finally reach at IOA 5A, and you guys, this is where the majority of your time is going to be spent in this unit. We are going to add and subtract 1- and 2-digit whole numbers using a variety of strategies. So you see day 1, we have concrete, and we are only focusing on addition at first. So we're going to add 2-digit plus 1-digit without regrouping. And all of these are going to be result unknown or whole unknown, relevant problems in context. We would also like to see those part-whole graphic organizers being utilized. And again, this is concrete, so we're working with base 10 blocks. The next day, we're going into 2-digit plus 1-digit with regrouping. So this would be their opportunity to bundle 10 ones to compose a new 10. So still just 2-digit plus 1-digit concrete. Then we're going to go, okay, we have 2-digit plus 2-digit without any regrouping, really just getting them to see we add 10s to 10s and 1s to 1s. Base 10 blocks, place value chart, part-whole organizer. And then we're going to do 2-digit plus 2-digit with regrouping. So we have our 2-digit numbers, and students are going to need to bundle 10 ones and compose a new 10. Again, notice whole unknown or result unknown problems that are relevant to our students. So we've spent several days using concrete manipulatives. Now we're going to get into more of those representational strategies. So we're backing up just a little bit. We're going back to adding 2-digit plus 1-digit. We are going to do with and without regrouping, since we've already had some experiences with regrouping. On this day, we're going to draw base 10 blocks. Continuing to use part whole. The next day, we're going to progress to using a number line. So you're able to make that connection to what the base 10 blocks mean with your number line. Now we're at representational 2-digit plus 2-digit with and without regrouping. Back to base 10 blocks. The next day, we're doing 2-digit plus 2-digit with and without regrouping using a number line. So lots of opportunities for students to be exposed to strategies, but then allowing them the opportunity to be flexible and choose which strategy works best for them. So after working with addition, students are going to return back to concrete, and we are going to work with subtraction. The instructional progression for subtraction is very similar to what we did with addition. So we have our first day. I'm going to slide this down just a little bit. We're back to concrete. We're doing 2-digit minus 1-digit without regrouping. Again, result unknown problems, part whole organizer, and we're using those base 10 blocks. So a day at concrete without regrouping. And then the next day, we're going to regroup. We're going to decompose the 10 into 10 ones. Sticking with concrete, we're going to 2-digit minus 2-digit without regrouping. So we subtract ones from ones and tens from tens. And the next day, 2-digit minus 2-digit with regrouping. So they're going to have to decompose the 10 into 10 ones. So very similar to what we did with addition. Lots of concrete practice before we get into those representational strategies. So we have 2-digit minus 1-digit, and they're going to draw those base 10 blocks. And here we're sticking with and without regrouping, because we've already done with and without regrouping concretely. The next day, we are going to expose them to another strategy. They can subtract 2-digit minus 1-digit on a number line. And then 2-digit minus 2-digit with and without regrouping, drawing those base 10 blocks using your place value chart. Again, you continue to see the part whole organizer. And these story problems are going to continue to be result unknown. Then we're going 2-digit minus 2-digit with a number line. So the capacity of the numbers is really mimicking what we did with addition. During the final 4 days of this unit, students are going to do addition and subtraction. So this really gives them the opportunity to work on determining which operation is going to be used. So really, really fun task-based opportunities at the end where they are really working and applying everything that they learned in the unit. Now, thinking about the entire unit, there is one thing that I want to point out that I haven't talked through yet is, and just like in previous units you've seen for first grade, the activating strategies are very intentionally paced out. So something to notice is some of the days, like this day right here, you'll see a notice and wonder for data. Although IOA 6D, which is your data IOA, is not included on the instructional calendar, we still wanted to give students the opportunity to engage and continue thinking and doing some extra questioning about graphical displays. So we've embedded some of that for you guys to continue to practice. We also have number talks embedded that is going to work on their fluency to really help with those addition and subtraction strategies. And then earlier I did point out the 10 more, 10 less. I'm looking for a specific day where it's listed out. We have 10 more, 10 less that is included to continue to build on the IOA 5A that you did in the beginning of the unit. So again, those activating strategies are intentionally designed to continue to work on some previous skills and build skills that are going to help your students be fluent and better with the adding and subtracting within 100. So I hope this was helpful, and thank you so much. Now let's look at how to compose a new 10 when we are adding a 2-digit number plus a 1-digit number. Here is our scenario. Cameron has 46 Pokemon cards. His mom buys him another pack of 6 cards to reward him for having a great week at school. How many Pokemon cards does Cameron have now? Before I get started solving the problem, I want to picture what is happening. I know that Cameron has some Pokemon cards and his mom buys him some more cards because he had a great week at school. I can see in my head Cameron's mom giving him additional Pokemon cards, giving him more cards. I know that I can organize what's happening in this story problem in my part whole to help me figure out the equation that will help me figure this out. So when I'm looking at this story problem, I see that Cameron started with 46 Pokemon cards. His mom buys him 6 more. And we want to know how many Pokemon cards Cameron has now. So what's the total number of Pokemon cards that Cameron has after his mom gives him 6 more? So if I'm looking for the total number that Cameron has, that's going to be my whole. I am looking for how many cards Cameron has now. The total number of cards. I know that Cameron started with 46 cards and his mom gives him 6 more. So if I put the 46 cards and the 6 additional cards that Cameron's mom gives him, then together, then I will find that total number. So I know the equation that would help me find this is 46 plus 6, and that's going to give me that total amount of cards that Cameron has. So now that I understand what is happening in my problem and I have my equation, I want to build a model to solve it. So I'm going to use a place value chart to help me keep my numbers organized. So I'm going to have my 10s and my 1s organized in this place value chart. I see that Cameron started with 46 cards. So I'm going to show the 46 cards that he started with. I know 46 is composed of 4 10s and 6 1s. 1, 2, 3, 4, 5, 6. Then, so I'm going to write 46 over here to represent the cards he started with. Then I know that his mom gave him 6 more cards. 6 would be represented by 6 1s. 1, 2, 3, 4, 5, 6. Double them up so that we save some space for our camera. Okay, so this represents the 6 cards that Cameron's mom gave him. So now I want to start adding in the ones place, because if I have more than 10 ones, I can compose a new 10. So let's see. I know that 6 and 6 more is 12. So I am going to need to compose a new 10 because I have 12 ones. So I'm going to circle my group of 10 to help me stay organized. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let me draw a circle around that group of 10. That is a group of 10. I know that 10 ones is the same thing. 10 ones is the same as a tens rod. So I composed a new 10. So I'm going to draw an arrow to show where those 10 ones are now represented by that new tens rod. So now I see that I have 5 tens. 5 tens has a value of 50. And I'm going to slide this up so you guys can see. 50. And I have 2 ones, which has a value of 2. I know 50 and 2, or 50 plus 2, equals 52. I can also check that by counting 10, 20, 30, 40, 50, 51, 52. So that means now Cameron has a total of 52 Pokemon cards. Now the next step with this, after students have had enough time with concrete manipulatives in their base 10 blocks, you can have them draw a representation. So it would look very similar. Again, I would have my 10s and my 1s. I would represent 46, 10, 20, 30, 40, and 6 ones. 1, 2, 3, 4, 5, 6. And then the 6 ones from the cards that 1, 2, 3, 4, 5, 6, 46, and 6. Now I know again that I can compose a 10, so that's 6, 7, 8, 9, 10. And I would draw my new 10. I see again that I have 50 and 2, which is 50 plus 2 equals 52. So really getting your students to just basically do what they did with the base 10 blocks, but drawing a picture of that. In this video, we're going to see how to subtract a 2-digit number from another 2-digit number. So here is our scenario. Miss Zanardo bought a bag of candy to use as classroom treats. The bag came with 50 pieces of candy. On Monday, she gave away 12 pieces of candy. How many pieces of candy does Miss Zanardo have left in the bag? When I read this problem, I'm going to make a math movie in my head and picture what is happening. I can see the bag of candy that Miss Zanardo bought had 50 pieces in it. And I can see that she is giving away pieces of candy, so there's going to be less candy left in the bag. She's giving away 12 pieces. And my final thing I want to figure out is how much candy is left in that bag. I am going to use a part-whole organizer to set up my problem so I can figure out what equation I would use to solve this problem. I know that the bag of candy started with 50 pieces. This means 50 needs to be recorded in my whole because it was the whole bag of candy that she started with. I know that Miss Zanardo gave 12 pieces away. This is a part of the 50 pieces of candy. She gave away 12. So candy given away. That part came from that bag that she had to begin with. I know that the other part is the candy that's left in the bag. And that is what I'm looking for. That is what I'm trying to find in my problem, how much candy was left in that bag. So that's my missing information. Now I know that this part whole can help me determine my equation. I know that when I have the total or whole, I can subtract a part to find the other part. So let me think about that. If I started with 50, the whole bag of candy, and I subtract the 12 pieces that Miss Zanardo gives away, then I will be left with what's in the bag, what I'm looking for. So that makes sense to me. So the strategy that I'm going to use to solve this problem today is I'm going to use a place value chart with base 10 blocks. I am going to begin by drawing my tens and ones chart. And I know that I am starting with the whole bag of candy, the 50. I know 50 is composed of 5 tens and 0 ones. So I'm going to model 50 using 5 tens. 10, 20, 30, 40, 50. Now that I have represented my total number of pieces of candy in the bag, I can subtract the candy that Miss Zanardo gave away. The number 12 is composed of 1 10 and 2 ones. I know that I need to subtract 2 ones, but I notice that I do not have any ones right now. This means I need to decompose a 10 into 10 ones. So I'm going to have to decompose that into 10 ones. So when I take my tens rod, I can see that it is equal to 10 ones. So I'm going to decompose that 10 into 10 ones. Now, I still have 50 represented by my base 10 blocks because 4 tens and 10 ones is the same as 50. 10, 20, 30, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Now I can subtract my 12 from my 50. Again, I know I needed to subtract 1 10 and 2 ones. 1 10 and 2 ones have been subtracted. So I see that I have 3 tens, which is 30, and 8 ones, which is 8. 30 and 8 equals 38. I can check my work by counting 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38. So Miss Zanardo has 38 pieces of candy. 50 minus 12 equals 38. 38 pieces of candy left in her bag. Now, after students have had ample practice using those base 10 blocks, you can do the same lesson but with representational. So you can see I've already set up my part whole, written my equation. But to model this using a drawing, I would draw my 5 tens, 10, 20, 30, 40, 50, and show the decomposing the 10 into 10 ones with a picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I can subtract 1 10 and 2 ones. 1, 2. And that would leave me again with 38. Today we've talked about different strategies. We've also talked about using concrete, representational, and abstract strategies in the previous video. So which strategy should we emphasize? In mathematics, the emphasis is on reasoning and thinking about quantities within mathematical context. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards persevere and affirm local control and flexibility. Thank you for watching our video today.